37 integral from 0 to infinity dx over 1 plus x times square root x. This is improper because the upper limit's infinite and we have a domain restriction. X cannot be -1, but we're not going there in the limits, so we're okay. But x also cannot be 0, and we do go there. So this is a double improper integral. So we got to rewrite it a little bit. I broke it up from 0 to 1, 1 to infinity. Okay, this integral, if it's an indefinite integral, is actually not bad to evaluate, and actually do that in a bit. Okay, so we got to figure out if both these pieces converge. If one of them diverges, this original guy diverges. If both converge, then this original guy converges. Okay? The second one, I chose to do the easier one first. We can do a comparison test. Okay? So if I write it in exponents instead of a radical here, it would become like this. And this is less than or equal to 1 over x to 3/2 power for x is greater than or equal to 1. And we know this guy converges because this is 1.5, which is greater than 1. You can also just evaluate it if you really want to. But I'm assuming your professor or grader will allow this. So by comparison test, since our guy is even smaller than this guy, our guy is going to converge as well. Okay, so this piece converged. How about this one? This needs to converge as well for the original to converge. So this is where I just chose to evaluate it instead of trying to figure out another comparison. Okay, because this one is not as easy to determine the comparison for. Okay, so I just chose to directly evaluate it. I did a substitution. U is square root of x. Du is 1 over 2 root x dx. So if I substituted, I would get this right here, which is the arctangent. Okay, and then I back substituted. So the improper integral from 0 to 1 of this guy is, I use the antiderivative over here, fundamental theorem calculus, and the limit definition, 2 steps in 1 over here. Evaluate it, it's pi over 2. So it converges. Both pieces converge. Our original guy converges as well. Okay, once again, since I evaluated it here, you can just use the antiderivative to evaluate this piece as well if you really wanted to. But since I chose to evaluate or show the convergence of this first, I didn't have to evaluate it because it's quite easy for me to use a comparison to do that. But this one, I didn't want to think of another comparison, so I just directly evaluated it like this, which was not bad at all.